Hey kids, welcome to section 3.4 Exploratory Data Analysis. Today we're going to use the techniques of exploratory data analysis, including box plots and five number summaries, to discover various aspects of data. Sounds like something super important, exploratory data analysis, but it's not. So, in exploratory data analysis or EDA, data can be organized using a stem and leaf plot or a box plot, sometimes called a box and whisker plot. And the purpose of exploratory data analysis is to examine data to find out what information can be discovered about the data, such as center and spread. So we're going to take data, we're going to graph it into a box plot, and then we're going to explore the various calculations that come from it. The most popular exploratory data analysis is box plots. They need five specific values in order to draw them. You need the minimum, you need quartile 1, Q1, the median, which is quartile 2, the third quartile, Q3, and the maximum. If you have these five numbers, they're referred to as the five number summary. That five number summary is what you're going to use to draw a box plot. So the procedure for drawing a box plot, find the five number summary, and then we're going to draw it on kind of a number line. But yeah, the whole point of a box plot is so you're going to have something that kind of looks like this. And when you have this box plot, it cuts it into using quartiles for equal sections. And so you have 25% of the data in the first one, group. You have another 25% on that side. You have another 25% here, and you have another 25% here. So remember, you've got quartile 1 and you've got quartile 3. Here's your maximum over here on the right. Here's your minimum over here on the left. And then you have your median in the center. So you've got a way to chunk your data into four equal groups using the three quartiles. All right, well, let's see how to draw a box plot and then we can see why we use it. So the number of meteorites found in 10 states of the United States is found below. Construct a box plot for the data. Well, in order to draw a box plot, I need a minimum. I need a Q1. I need a median. I need a Q3. And I need a maximum. The easiest way to find those five numbers is to first organize your data from smallest to biggest. So if I go smallest to biggest, I have 30, 39, 47, 48, 78, 89, 138, 164, 215, 296. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect, I got 10. All right, so now that it's in order smallest to biggest, I can find my minimum really quickly. That's 30. My maximum really quickly is 296. My median's going to cut the data in half, which means 5 on one side, 5 on the other. So we're looking at a 1, 2, 3, 4, 5. Median's going to be right there in the middle. So we're going to take 78, we're going to add 89, and we're going to divide by 2. That gives me 83.5. Well, then my quartile 1 is the middle of the left side. That's going to be 47. And my Q3 is the middle on the right side. That's 164. Now that I have my five number summary, I can draw. So we're going to side line. My minimum's 30, my max is 296, so I'm going to go 0 to 300. So I'm going to put 0 here, 100, 200, 300. And I'm going to go and put in my 50s. 25, 75, 50, 50, 75, 50. All right. Now, for each of the 5 numbers, we're going to put a small vertical line. So graphically, 30 would be right here, and 47 would be a little bit closer to 50. 83.5 would be somewhere about there. 164 would be about here, and 296 would be about here. So once you get your 5 marks for each of your 5 numbers, then you're going to connect the middle 3 into a box. And then you're going to connect the whiskers through the middle. There is your box plot. So if we want to talk about this, do you see how this right tail, or this right side, is so much bigger than my left side? Well, that longer right side means that this is positively skewed. Because of that longer right tail. Right tail is longer. So that tells me my skew. I can also take a look and see that the bottom half of my data is a lot smaller in width than the top half of my data, which means the top half is really spread out and the bottom half is really close together. So that can tell you a lot about your data. Okay, so if the box plots for 2 or more data sets are graphed on the same axes, then the distributions can be compared. So to compare the averages, we're going to use the location of the medians. And to compare the variability, we're going to use the interquartile range or the lengths of the boxes. So to compare the averages or the means, we're going to use the location of the medians. To compare the variability or the standard deviation, we're going to use the interquartile range. So we can get a lot of information from this box plot. 1A, we can say if the median is near the center of the box, then the distribution is symmetric. If the median falls to the left of the center of the box, the distribution is positively skewed. If the median falls to the right of the center, the distribution is negatively skewed. So if we have a box in the middle, it would be symmetric. If we had a box and the median was to the left of the center, then it's positively skewed. And if we have in the box it closer on the right-hand side, then that would be negatively skewed. If the lines are the same length, the distribution is symmetric. So if we have, this has to do with the whiskers. So if we're looking at the lengths of the whiskers, so if they're the same length, then they're symmetric. If the right whisker is longer, then it's positively skewed. So if it's right, it's positively. If the left line or whisker is longer, then it's negatively skewed. So we talked about that on the previous slide. And I guess I should say that then 1 is the box. So you can compare box using mean and compare the whiskers for the standard deviation. All right, so let's compare. So we have a dietitian who's interested in comparing the sodium content of real cheese with the sodium content of a cheese substitute. The data for the 2 random samples are shown. Compare the distributions using box plots. Okay, so we have to do 2 box plots, 1 for each of the sets of data. So let's do the real cheese first. All right, so first we should organize the data smallest to biggest. So I have a 40 and a 45 and a 90 and 180, 220, 240, 310, and 420. So I need my 5-number summary. So the min is 40, the Q1, and then let's see, there's 1, 2, 3, 4. So I split it in the middle. That's going to be my Q2. My median is going to be in between 180 and 220. So 180 plus 220 divided by 2. So my median is 200. So now that I know my median, I can go back and say that my Q1 is going to be in between 45 and 90. So if I do 45 plus 90 and divide by 2, I get, let's get this for a little bit. I get 67.5. So I got my min, I got my Q1, I got my median. Okay, I need Q3. Q3 is going to be in between 240 and 310. So I need to do 240 plus 310 and divide by 2. That's going to give me a Q3 of 275. And then I need my max. That's 420. All right, so I got my real cheese numbers. Now I got to do my substitute. Okay, so first put my numbers in order. I got 130, then 180, then 250, then 260, and 270, 290, 310, and 340. All right, I need my min, which is 130. Then I'll find my Q1. I can find my median. And then eventually my max. My max is 340. I can do that one. That's pretty easy. Okay, and then, then my Q3. Okay, so it looks like my median is going to be in between 260 and 270. So 260 and 270 divided by 2, that's 265. Then I can put my Q1 in between 180 and 250. So if I do 180 plus 250 divided by 2, that's 215. My Q3 is going to be over here between 290 and 310. So 290 plus 310 divided by 2, that's 300. Okay, so I have my 5-number summaries for each. Now I'm going to draw. Now, I'm going to stack them one on top of the other. I'm going to put the real one on top, and I'm going to put the substitute one on the bottom. Remember, my mins are going 40 to 420, and then 130 to 340. So it looks like, I don't know, if I go 0 to 450, we're probably going to be good. So let's start this at 0, 100, 200, 300, 400, 500. All right, so we label these. I'll go back and put my 50s. Helps me to visualize a little bit more. All right, let's do the substitute one first because it's going to go on the bottom. So the minimum is 130. Remember, that's 150. So 130. Q1 is 215. So this is 250. Might be helpful to put these in. So 215 would be like right here. The median 265. I'll say right there. Q3 is 300. And the max is 340. Okay, so here is my super straight, perfectly drawn box plot for the substitute. cheese. All right, let's stack it with the real cheese. Okay, the new minimum is 40. Try to make it just as tall so you don't purposely emphasize. 67.5 is Q1. 200 is the median. Then 275 is Q3. And 420 is the max. So let's hope that these turned out a little bit straighter. And draw your whiskers. Okay, and this is the real cheese, the goat. That's funny because it might have come from a goat. All right, so we've got real cheese on the top box plot and substitute cheese on the bottom. Now we need to compare. So what can we say about these two sets of data? Well, let's see. In terms of whisker length, it looks like the real cheese is positively skewed, and the substitute cheese is negatively skewed. So we can say real cheese data is positively skewed. Versus substitute cheese is, well, they have a longer left tail, so that's negatively skewed. Okay, let's see, what else can we say? Well, we can say that the real cheese has a wider range, which means the values are more spread out. We could also say that the substitute cheese values are more consistent. We could say they have less variation. So maybe we'll say the real cheese data has greater variation than the substitute cheese. Oh, substitute. All right, so pay attention to how wide the box plot is. Pay attention to how long the whiskers are. Okay, one more example on how to draw a box plot. These data represent the volumes in cubic yards of the largest dams in the United States and in South America. Construct a box plot of the data for each region and compare the distributions. Okay, so we have United States and South America, and we're comparing the volumes of the largest dams. All right, so let's do the US here. We'll list the min, Q1, the median, Q3, and the max. And then we'll do South America. And we will do the min, Q1, the median, Q3, and the max. Okay. What's nice about these numbers is they're already in order largest to smallest. So we can kind of use it to our advantage to find where the different values are. So it looks like in the US, the minimum is 50,000 and the maximum is 125,628. In the United States, there are 1, 2, 3, 4, 5, 6, 7, 8 values. So 4 would be the cutoff. which means if I add 77,700 with 66,500, I will get a median of 72,100. My Q1 is going to be oh, that's my Q3 actually. My Q1 is down here at my low numbers. My Q1 is going to be in between 52,435 and 62,850. If I do that, I get $57,642 or 42.5. My Q3 is going to be up here in my larger numbers between 92,000 and 78,008. If I find that, my Q3 is 85,004. Okay, over here in South America, I have 6 numbers. So 3 is my cutoff for my median. So my minimum is at the bottom, 46,563. My max is up at the top, 11,539. My median is going to be in the middle here. If we add those two and divide by 2, 103,979. My Q1, ooh, these are really easy because there's an odd number of numbers. My Q1 and my Q3 are easy to spot. No calculation necessary. So my Q1 is 56,242 and my Q3 is 274,026. So if I go over here and I draw my box plot, let's see, minimum is 46. Maximum is 311. So I don't know, we go 0 to 400 or 0 to 300,000. Let's see, here's 0. Here it can be 100,000. Here it can be 200,000. And here it can be 300,000. If need be, we can extend this and make over here be 400,000. I'm going to put my marks back in. Okay. So let's see, let's do US on the top and we'll do South America on the bottom. Okay, so South America first. Minimum is 46. So that would be just to the left here. Maximum or Q1 is 56. That's on the other side. Median's 103. Q3 is 274. Wow, it's all the way over there. And the max is 311. All right, so here is South America. Well, South America. Interesting. Okay, if we do the US, min is 50, so it's relatively the same. 57, also very similar. 72, so that's 75. We'll say right there. Q3 is 85. Okay, maybe right there. And the max is 125. Well, take a look at this one. What do you notice? I mean, the cubic yards ones, there might have been more readings, but its entire box plot can be found within almost the bottom half, which is interesting. So overall, what can we say? Well, we can say that the range is extremely, extremely bigger than the range for the United States. We can also say that the standard deviation or the variation just in general of the dams is considerably larger in South America than the US. So we can say that the range and variation in the capacity of dams in South America is considerably larger than in the United States. All right, kids, that's the end of section 3.4. If you have any questions, please let me know. And as always, keep calm and keep trucking.